I warned you the fourth problem wasn't going to be as easy, but nope, you kept going, didn't you? So here it is, number 4. Now, number 4 is also concerned with impulse, but instead of starting at a dead stop, you're starting at a full run. While you're at a full run, what happens? You are accelerated up to the velocity of your car. So it's like your car drives by, you reach out to grab it, and then all of a sudden, woo! Suddenly you're not running. You're flying along at your car's max velocity. So, the question is, how much impulse was required to get you from your max running velocity to your max driving velocity? Well, we're going to find out. So, impulse is equal to the change in momentum, which, let's think about it. Now, it's not your car's momentum, it's you. So, is my mass times the final velocity minus, sorry, that's supposed to be an equal sign, mass times the initial velocity. My mass has not changed much by this, so I'm still 108.9. Your mass is going to be different. My car's final velocity is 42 meters per second. Initially, I'm still 108.9 kilograms. That's a K. Can you tell us a K? No, maybe I'll just take it out. Okay, forget about the kg. But my initial velocity was 5.6 meters per second. So, talk is cheap. Let's do some math here, okay? So, going to just kind of run down through this. When I multiply these together, when I did this, my calculator is currently on my camera, so I'm not doing it right now. I got 17,173 kilogram meters per second. That's how fast, that's what my momentum is when I'm holding on to the car dear life. It doesn't include the car, it's just me. Obviously my car is a lot more. My car is more massive, even at the same speed, it's got more momentum. Now, let's figure out what I started out with. Well, we figured this out a few times already, but we'll just go through, I do the calculation, it comes out 609, blah, 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 0.84. So, kg meters per second. I subtract them, and I get something like 16,563 kilogram meters per second. Now, two sig figs, it can only have two sig figs in the answer. So, or actually, hold on a second here. Well, it can only have two sig figs in the answer, which comes out to about 17,000 kilogram meters per second, or if you prefer, 17,000 Newton seconds. So that is the impulse required for me to go up to about from 5 to 42 meters per second. That's my impulse. All right. Your answer will, well, it's hard to say whether your answer will be bigger than mine. There's reasons for both. One, you're probably not as big as you. Or probably not as big as me. So at any of these speeds, your numbers are just going to be smaller. Smaller number, subtracting a smaller number, is still going to be a smaller number. So that's a reason why you might get a number that's smaller than mine. But you may also get a number that's bigger than mine, because there are two things in fact. One is that you're probably smaller than me, which will probably make it smaller, but there's another factor. Your car's max speed is probably higher than mine, which means that your final momentum when you're going your car's max speed might be considerably bigger than this, just because your car is faster. That could be the case too. That's going to certainly move for higher numbers. You may end up getting a much higher number based on that. Again, it all depends on your numbers. As long as you use your numbers, your answer will be correct. I'll see you later. Bye-bye now.